Welcome to Module B1 of the NATMed Training Program. This module presents a practical, step-by-step guide for the design, delivery, and long-term sustainability of full water cycle nature-based solutions in the Mediterranean context. Building on the experience of the NATMed project and aligned with the IUCN Global standard for nature-based solutions, it translates evidence, good practices, and lessons learned from real-world case studies into a clear and actionable framework. In this module, you will gain practical information to support the development and implementation of full water cycle nature-based solutions. You will receive clear guidance on the key steps to follow, starting from the identification of societal challenges and continuing through implementation, long-term operation, monitoring, and scaling up. You will also develop an understanding of the main aspects that need to be considered when implementing nature-based solutions, including ecological, social, economic, governance, and sustainability dimensions. This module is designed for decision-makers who are shaping policies and strategies related to nature-based solutions and water management. It is also intended for technical experts and practitioners involved in the design and implementation of nature-based solutions. Local and regional authorities, particularly those working on planning, sustainability, and water management, will find this module highly relevant. In addition, it addresses small and medium-sized enterprises, as well as other stakeholders involved in the development and delivery of nature-based solutions. Let's start by briefly setting the background and foundation of these guidelines. Within the NATMed project, a series of full water cycle nature-based solutions have been designed, implemented, and evaluated across 5 Mediterranean countries: Spain, Greece, Italy, Turkey, and Algeria, as introduced in Module A1. These interventions address challenges that are common across the Mediterranean region, while at the same time responding to local conditions. They were assessed using the IUCN Global standard for nature-based solutions, which is covered in Module A2. This assessment process allowed us to identify good practices across multiple dimensions of NbS implementation, including project design and planning, governance approaches, social innovation, biodiversity conservation, innovation and scaling up, as well as monitoring and evaluation. At the same time, it helped us clearly identify areas where further improvement is needed, leading to the formulation of these guidelines, designed to assist nature-based solution practitioners in developing projects and interventions by providing practical information and clear guidance on the steps to follow, and the key considerations across the entire life cycle of a nature-based solution. These guidelines are structured as a step-by-step implementation pathway that follows the entire life cycle of a nature-based solution. Each step builds on the previous one, so the guidelines are meant to be read sequentially. At the same time, it's important to recognize that implementing nature-based solutions is not a linear process. As new information emerges, it may be necessary to revisit earlier steps and adjust decisions accordingly. For this reason, the guidelines are intended as a practical reference rather than a rigid manual. Users are encouraged to adapt the recommendations to their local context, institutional setting, and available resources, and to apply them flexibly throughout the entire duration of the intervention. Step 1 focuses on identifying the societal challenges of the area and their underlying drivers. This is the starting point for implementing any nature-based solution. Practitioners should identify societal and water-related challenges at national, regional, and local levels, using existing sources such as climate risk assessments, sectoral reports, scientific studies, previous projects, and local experience. It is important to consider both short-term and long-term challenges, using projections where available. In the Mediterranean context, this means taking into account climate change impacts, population growth, tourism pressures, and land use changes. The process should move from general challenges to clearly defined, site-specific issues supported by evidence. You can align your challenges with IUCN's major societal challenges that nature-based solutions can address, as shown in this slide. At this stage, the drivers behind each challenge should also be identified and documented. These may include climate change and extreme events, over-exploitation of natural resources, poor water or land management practices, and pollution or other human-induced pressures. Special attention should be paid to rapidly changing environmental conditions, such as water quality deterioration, the spread of invasive species, and ecosystem degradation that may affect nature-based solution performance. Biodiversity-related challenges should always be included, as biodiversity enhancement is a core requirement of nature-based solutions. The second element of this step is stakeholder engagement. Transparent and inclusive consultations are essential to capture local knowledge, identify priority challenges as perceived by affected groups, and include perspectives from local communities, vulnerable groups, authorities, researchers, and decision-makers. This process also helps build trust around the proposed interventions and should be guided by a clear governance and participation plan. Finally, all identified challenges and drivers should be clearly documented and communicated. Information should be accessible and shared with stakeholders, and awareness should be raised about the challenges, their causes, and the potential role of nature-based solutions in addressing them. Step 2 focuses on developing a theory of change and an NbS strategy. Once societal challenges and their drivers have been identified, this step helps link the proposed nature-based solution to clear and measurable outcomes. The first element is the definition of clear objectives and a theory of change that directly responds to the identified challenges, covering well-being, socio-economic, water-related, and environmental outcomes. The theory of change explains how the proposed NbS are expected to deliver results, including benefits for people, biodiversity, and ecosystem integrity. Biodiversity enhancement and ecosystem integrity should always be included as horizontal objectives, and the assumptions behind the theory of change should be clearly justified using scientific evidence or documented experience. The second element is the development of the NbS strategy. This strategy organizes the intervention steps across environmental, social, economic, and institutional dimensions, taking into account partners, timelines, expected results, corrective actions, transferability, and long-term sustainability. Clear outcomes and benchmarks are defined to measure progress over time. Finally, stakeholders should be actively involved in developing both the theory of change and the NbS strategy. These elements also form the basis for monitoring, evaluation, and adaptive management, allowing the intervention to be adjusted if risks, gaps, or deviations from expected results are identified. Step 3 focuses on identifying, assessing, and prioritizing full water cycle nature-based solution options that can effectively address the identified societal challenges and their drivers. The first part is to develop a set of solution options. This involves creating an NbS catalog that includes a range of potential nature-based solutions aligned with the defined objectives, biodiversity goals, and NbS strategy. Importantly, the catalog should also include grey or conventional solutions so that different options can be transparently compared. Visual and comparative tools such as cost-benefit matrices, trade-off maps, or decision support systems can support participatory discussions with stakeholders. Next, each option is assessed against key criteria, including its ability to address the identified challenges, the co-benefits it provides, stakeholder acceptance, economic feasibility, efficiency, and potential risks or trade-offs. Finally, during this step, solutions are selected and prioritized based on the local context, taking into account environmental, socio-economic, governance, and cultural conditions. Priority should be given to solutions that are environmentally sustainable, replicable, and manageable by local stakeholders. Local perception surveys and continuous dialogue with stakeholders help ensure acceptance and allow solution choices to be refined where necessary. Step 4 focuses on selecting the nature-based solution and ensuring its economic feasibility and long-term sustainability. The first part involves assessing costs, benefits, and economic robustness. This means identifying all direct and indirect costs and benefits over the short, medium, and long term, including economic, environmental, social, and well-being effects. It is particularly important to include non-market benefits, such as ecosystem services and human health, even when these cannot be fully monetized. The assessment should clarify who benefits from the solution and who may bear costs or trade-offs, and apply appropriate methods such as cost-benefit, cost-effectiveness, or multi-criteria analysis. Key assumptions should be clearly documented and tested using benchmarking or sensitivity analysis to account for uncertainty. Finally, the results of the economic assessment can be used to make an informed decision on the NBS to implement, optimize design choices, and support long-term environmental and economic sustainability. Stakeholder involvement is critical in this step as well. Engaging stakeholders in discussions on costs, benefits, and funding helps capture local knowledge, improve acceptance, and ensure transparent decision-making. Finally, securing long-term sustainability requires analyzing funding sources, developing a portfolio of resourcing options, exploring green business models, and including economic indicators in the monitoring and evaluation plan so that costs and benefits can be tracked and adjusted over time. We now move on step 5 to integrate biodiversity and ecosystem improvement goals as core cross-cutting priorities of full water cycle nature-based solutions. Biodiversity net gain and ecosystem integrity should be embedded throughout the entire NBS lifecycle, from design to implementation and monitoring. The first element of this step is to assess ecosystem conditions and define biodiversity objectives. This involves establishing a clear ecological baseline at both site and landscape level, including information on ecosystem structure, species composition, ecosystem functions, soil and water quality, ecological connectivity, and existing pressures. Understanding degradation processes and their drivers using scientific data as well as local or traditional ecological knowledge is essential. Based on the ecological baseline and the NBS strategy, clear biodiversity and ecosystem improvement objectives can be defined and aligned with conservation policies. Biodiversity is then integrated into implementation, monitoring, and risk management through appropriate indicators, impact reviews, and regulatory compliance. Finally, NBS design should enhance ecological connectivity and deliver wider socio-economic and cultural co-benefits, with continuous stakeholder engagement to identify biodiversity values and local restoration priorities. As we have seen, stakeholder engagement is important in all steps so far. Next step provides the structure for this approach by developing a participation and governance plan, which is essential for the successful implementation, social acceptance, and long-term sustainability of the interventions. Effective governance starts early. A participation and governance plan defines how decisions are made, who is involved, how roles and responsibilities are distributed, and how conflicts are managed. This includes mapping all relevant stakeholders, such as landowners, farmers, local authorities, citizens, SMEs, and vulnerable groups, and clearly identifying their rights, potential benefits, and possible trade-offs. Clear arrangements for land and water access and use rights should be established, along with transparent decision-making, dialogue, and grievance mechanisms, so stakeholders know how concerns can be raised and addressed. Inclusive and continuous participation is a core element of this step. This means actively engaging vulnerable groups, ensuring gender balance, involving young people and local communities, and using participatory tools such as co-design sessions, public consultations, and digital platforms. Finally, participation should be embedded in implementation, monitoring, and long-term sustainability. Stakeholders can contribute local knowledge, validate results, support cross-sectoral collaboration, and strengthen community ownership, helping ensure that nature-based solutions are effective, trusted, and sustainable over time. Step 7 is all about monitoring and evaluation, two essential practices for tracking performance, assessing whether nature-based solutions are effectively addressing societal and environmental challenges, and supporting learning and adaptive management. The first part is defining key performance indicators. These indicators should be clearly linked to the objectives, assumptions, and theory of change set out in the NBS strategy. They need to cover ecological, socio-economic, and human well-being aspects, including biodiversity and ecosystem integrity, and they should be SMART, meaning specific, measurable, achievable, relevant, and time-bound. The monitoring and evaluation plan then defines what is measured, how often, and using which methods and resources. KPIs should be monitored periodically, both within and outside the intervention area, and reviewed regularly to detect risks, deviations, or unintended effects. Monitoring results are used to support iterative learning and adaptive management, allowing the NBS to be adjusted as new evidence emerges. Planning for long-term monitoring beyond the project lifetime, using digital tools and citizen science where appropriate, and involving stakeholders throughout the process helps build transparency, trust, and long-term impact. Next step looks at the identification and management of synergies and interactions to ensure that nature-based solutions work effectively across sectors and scales, maximize positive impacts, and minimize risks. The first part is identifying interactions between the economy, the environment, and society, and integrating them into the NbS strategy. This includes assessing how the intervention may affect local livelihoods, productive activities, ecosystems, and even areas beyond the intervention site. It also means identifying synergies between NbS and other actions, such as engineering projects, conservation initiatives, financial instruments, or technological solutions. NbS should be aligned with relevant local, regional, national, and international policies, including the Sustainable Development Goals. They can support existing plans such as green infrastructure, climate adaptation, or water reuse strategies, and in some cases help shape new policy approaches. Finally, it is important to identify and manage risks, such as land or water use conflicts or public acceptance issues. Stakeholder involvement and clear documentation of synergies and risks help strengthen NbS performance and deliver wider socioeconomic and ecological benefits. Step 9 refers to risk analysis and the balancing of trade-offs. The first step is to identify and assess risks, interactions, and trade-offs between ecosystems, the economy, and society across different spatial scales and timeframes. It considers both internal and external risks over the NbS lifecycle, drawing on scientific evidence, local knowledge, and stakeholder input, with particular attention to biodiversity, livelihoods, and public acceptance. Risks are then evaluated in terms of likelihood and impact and addressed through strong and equitable governance. The next element sets clear safeguards and limits for the identified risks and trade-offs, based on regulations, evidence, and local context. Corrective and contingency measures are defined in advance to prevent imbalances if limits are exceeded. Safeguards are regularly reviewed and adapted as conditions or stakeholder feedback change. All risks, trade-offs, safeguards, and corrective actions are compiled into a risk management plan integrated from the start of the NbS design. The plan is updated throughout the project lifecycle. Where possible, risk monitoring continues beyond project completion to support long-term stability. The next step is the drafting of a communication and dissemination plan to build understanding, trust, and long-term support for nature-based solutions and enable their replication, upscaling, and mainstreaming. The communication and dissemination plan must be prepared at the very beginning of the project. The plan defines objectives, target audiences, key messages, tools, timelines, and evaluation methods, and explains how NbS interventions affect both ecosystems and socioeconomic systems, highlighting benefits as well as challenges. Messages should be tailored to different audiences and technical information translated into clear, accessible, and locally relevant formats. Communication should also show how NbS contribute to wider goals such as human well-being, climate action, biodiversity protection, and the Sustainable Development Goals. Communication and dissemination take place throughout the entire project lifecycle, using a mix of channels such as stakeholder events, digital media, publications, and site visits, while explaining how citizens and stakeholders can actively engage. Monitoring and learning results are shared to support transparency and adaptive management, alongside targeted training and knowledge sharing to build capacity. All activities follow principles of transparency, inclusivity, and ethical engagement, supporting long-term learning and mainstreaming of nature-based solutions. Step 11 focuses on scaling up and replicating nature-based solutions by strengthening institutional support and embedding NbS into policies, regulations, and planning frameworks. The goal is to move from isolated projects to systemic change by influencing decision-making across governance levels. The first action involves mapping existing policies and regulations at local, regional, national, and international levels to understand how they affect your nature-based solution. It helps identify regulatory gaps and barriers, as well as opportunities to integrate NbS into sectoral and territorial policies. Updated scientific and technological knowledge can also inform the adaptation and improvement of legal and regulatory frameworks. The next action is the definition of clear policy goals, target institutions, and key messages, linking NbS to measurable impacts. Monitoring and evaluation results are used to demonstrate benefits and support evidence-based decision-making, while addressing institutional and political barriers through practical policy guidance. Policymakers are engaged from early stages and involved throughout project activities. Results are shared through integrated reports and linked to planning and policy processes, encouraging stakeholder participation and supporting the long-term uptake and scaling of nature-based solutions. This step focuses on ensuring the long-term sustainability, performance, and adaptive capacity of nature-based solutions through effective maintenance and operation over their entire life cycle. Maintenance and operation are planned from the outset as an integral part of the NbS life cycle. Activities are informed by continuous monitoring and evaluation and follow adaptive management approaches, taking into account system complexity, technical capacity, available resources, and site-specific environmental and climatic conditions. This element focuses on identifying and managing technical and environmental risks that may affect the performance of the nature-based solution, such as clogging, sediment accumulation, water quality risks, or ecological imbalance. Maintenance planning also considers social and contextual factors, including public acceptance, stakeholder engagement, tourism pressure, and coordination between multiple actors. Where possible, the use of automated monitoring systems is encouraged to improve decision-making and reduce costs, while acknowledging that long-term monitoring and technical follow-up may face budgetary or capacity constraints. The final step focuses on the tendering process, which is critical for translating co-designed nature-based solutions into practice. Conventional procurement approaches often struggle to address the complexity, adaptability, and multi-benefit character of full water cycle nature-based solutions. Traditional tenders tend to prioritize lowest cost and predefined outputs, making it difficult to capture ecological co-benefits, adaptive management needs, and community engagement. For co-designed nature-based solutions into practice, conventional procurement approaches often struggle to address the complexity, adaptability, and multi-benefit character of in particular. Challenges include regulatory uncertainty, limited site data, lack of contractor experience with ecological solutions, and the need to balance financial constraints with long-term operation and environmental safeguards. This action aims to adapt tendering practices to better reflect the specific needs of NbS. It starts with early mapping of regulatory constraints and robust site investigations, followed by clear, jointly prepared tender specifications. Evaluation criteria should prioritize technical and ecological expertise, not cost alone, and include operation and maintenance requirements from the outset. Early involvement of communities and authorities helps reduce conflicts, while transparent documentation and flexible timelines support learning, coordination, and long-term sustainability. Other aspects to foresee when implementing nature-based solutions include establishing coordinated management frameworks with local authorities, communities, and key stakeholders to strengthen governance and management capacity. In tourism-affected areas, ecotourism planning and on-site communication can help align NbS objectives with visitor activities, raise environmental awareness, and reduce pressure on natural resources. Synergies with agriculture, particularly in rural areas, support more sustainable soil and water management, while the use of standardized evaluation methods, such as the IUCN Global standard, enables learning, comparison, and the identification of good practices. And with this, we conclude the Module B1 on Implementation Guidelines for FWC-NbS in the Mediterranean. For access to all NATMed training modules and other useful resources, please visit our website. Thank you for your attendance.